Hi, my name is Leah Lambert, and today is January 24th, 2022. Today I'm going to be discussing two cases, case studies 2 and 3. In the first case, we are met with a female adolescent recently diagnosed with a deficiency of muscle glycogen phosphorylase. Her and her family have some questions and concerns for the doctor regarding her recent diagnosis. One of the first questions this patient asked is to explain how muscle glycogen is used normally during exercise. So to answer her, normally our bodies are going to require some sort of fuel to perform a particular exercise. So that fuel source that we use is called glucose. Now, under normal conditions, glucose will get stored in our bodies in the form of glycogen, which is just a stored form of carbohydrates in our muscles, which ultimately give us the energy to be able to perform exercise. So now what happens in this patient's case is she's missing a specific enzyme called glycogen phosphorylase, and it's going to be this enzyme that helps convert the glycogen to glucose to be used for energy. So in order to better understand this condition, we have to understand that it is an issue going on with glycogen storage, and where glycogen gets stuck in the muscles and is unable to turn into free glucose for the rest of the body to use. So this patient is wondering if she's still going to be able to take long walks. And the answer to that is yes. Walking is a form of aerobic activity. And with this activity, it requires a different form of fuel than one we would see, or one that would be used during, say, a marathon or heavy weightlifting. Now, these are activities that this patient is ultimately going to avoid because her muscles have the inability to break down glycogen. So normally we want our muscles to be able to break down glycogen and pump it out and turn it into glucose so that it can be used for energy. But that doesn't happen in this patient's case. So she's going to want to be cautious on the type of activities that she is able to perform, because high strenuous activities are going to put her at risk for muscle exertion, cramping, possible renal failure. So, as a result of this deficiency, one of her next questions asked is she's going to have to wake up in the middle of the night to maintain blood glucose levels. And the answer to that is also no. She's not going to have to do this because glycogen is never used to support blood glucose levels in our muscles. And that is because our muscles lack a particular enzyme called glucose 6-phosphate. And now what that enzyme does is it takes glycogen that is stored in the body and it converts it into glucose. But because our muscles lack this enzyme, it instead gets converted into lactate by our liver. So it's actually going to be the liver that is the major glycogen storage that provides glucose to be used by our tissues. So finally, the last question that this patient asks is she at risk for producing excess lactate during intense anaerobic activities? And the answer to this is no, because with this particular disease, also known as McArdle's disease, patients with McArdle's disease don't increase their blood lactate levels during or after intense exercises. This is due to blocked glycogenolysis. So as we discussed before, this disease involves issues with glycogen storage and also breakdown of glycogen. And this is why patients experience fatigue or severe muscle cramping soon after working out, because the glycogen gets built up. So studies have shown that lactate isn't just merely a byproduct of intense workouts, which originally was always assumed, but it contributes to overall skeletal metabolism. So studying patients with this particular disease, McArdle's disease, it has allowed us to understand this a little bit better and how those with this particular disease still rely on lactate as an important energy source during exercise. So now we're going to move on to the second case. Going to do case 3, which discusses a 5-year-old little boy recently seen by his pediatrician. He presents with multiple symptoms: drowsiness, persistent thirst, and frequent urination. Along with those symptoms, we're given his current lab or blood work showing his insulin levels in the fed and fasted state. So due to this patient's age, being very young, that lab work, and the current symptoms, the most likely underlying biochemical basis for the patient's symptoms lead me to believe that he has type 1 diabetes. So if we kind of break down those symptoms one by one, we can kind of see how I came to that diagnosis. So the first one, frequent urination, is often associated with high glucose levels in the blood. And with glucose being osmotically active, water tends to follow, and that is why we would also see a patient experience increased urination. And in addition to the increased urination, this patient is complaining of persistent thirst, which we shouldn't be surprised by. Frequent urination, which would cause this patient to experience dehydration, making him really thirsty. So now in type 1 diabetes, the body doesn't produce enough insulin. And if we compare the patient's insulin levels to the average, we can see that this 5-year-old is way below the average. Believe his levels are 0.8. Normal levels should probably be closer between 6 to 8, give or take. So what does this mean? Well, I would predict the patient's fasted blood glucose levels to be above the normal range. So normally the pancreas will produce insulin, and our liver and muscles will store that insulin as glycogen. So in this case, however, with the patient's low insulin levels, the pancreas is unable to signal to the liver and muscles to use up the glucose. And that is when we begin to see the glucose levels build up in the bloodstream. They have nowhere to go. So because ultimately is unable to enter the body cells. So it just stays in the bloodstream and builds up and builds up. So at this point, this patient would be at risk for hyperglycemia because glucose continues to build up. So based on this diagnosis of type 1 diabetes, I would hypothesize that the 2 regulatory enzymes that are active in this individual's current condition would be glucokinase and phosphofructokinase. So first, with glucokinase, this regulatory enzyme is considered the primary glucose sensor and is deemed as responsible for maintaining glucose homeostasis in the body. So I would expect this enzyme to be in play, to be increased in this child's case due to the imbalance of insulin to glucose that we see in this child's bloodstream with his lab work. So due to the low levels of insulin, the activity of the GCK enzyme to help regulate the release of insulin by B cells would help in the regulation of glucose homeostasis. And ultimately, that is what we're trying to accomplish. I mean, our bodies want to be in homeostasis. So the second regulatory enzyme that I thought that might be in play, that would be increased in this case, would be phosphofructokinase. Research has shown that insulin has regulated the expression of this enzyme, which impacted the regulation of glycolysis in the cell. And treatment specifically with insulin, it restored the activity of the PFK enzyme back to normal. So with that leads me to believe phosphofructokinase has an increased role in this patient's type 1 diabetes. And more specifically, the patients with very low insulin levels, since those were able to be restored with insulin. So that is all. Thank you.